Good afternoon. My name is Alexander Khlevloy, and I want to present our topic using machine learning methods for study of fire evacuation parameters in secondary education institutions with inclusive classes. Our team represents Lviv State University of Life Safety and Institute of Public Administration and Research in Civil Protection. Our work is dedicated to evacuation of children with special education needs from schools with inclusive classes. For the last 10 years, the number of pupils with special education needs in inclusive classes increased in 10 times. And for us, it is very important to provide the proper level of fire safety. To calculate the value of fire individual risk, it is necessary to calculate the duration of evacuation from the building. There are two groups of models that we can use for that. The first group is individual models. They provide the possibility to take into account the change in the movement speed of each evacuation participants. And the other group, flow models. The evacuation flow is assumed to be a homogeneous structure where all participants move according to a single establishing law of movement. It would seem that individual models are best suited for calculating the evacuation duration from schools with inclusive education, but studies of evacuation processes have shown interesting results. In case of fire, each class in school moves to a safe zone under the supervision of a teacher or an assistant of a teacher, and the teacher is personally responsible for all the children. So the children that are quick can't go to the safe place alone. They need to wait for all other and they need to wait for pupils with special education needs. So the scenario in which some pupils move faster and slower is impossible. At the same time, the use of individual models to reproduce such processes give significant deviations. So it is not convenient to use individual models for modeling of such process, such scenarios. Observation of evacuation in educational institutions with inclusive classes showed that effective duration calculation entails the use of flow models. So our task is to improve the group models and to make some improvement to allow taking into account the influence of pupils with special education needs on the speed of the flow movement. Our main documents which regulate the method of calculating the evacuation duration doesn't allow us performing such evacuation now. The initial data for the calculation are only partial cases. It allows us to perform calculation for ordinary schools where there are no participants with special needs in the evacuation flow. As for educational institutions with inclusive classes, there is not enough data for calculation in this document. Other documents, such as procedure for inclusive education organizing in secondary education institutions, tells that the number of pupils using wheelchairs, this is our object, to calculate how the percent of pupils using wheelchairs in the class and the average age of pupils influence on the speed of movement. There are no results, similar results in scientific or normative documents, so we decided to conduct such investigations. We also analyzed the scientific literature. Such works such researchers as Miyazaki, Matsakura, and Katsuhara model the dynamics of participants moving in wheelchairs, but the paper considers the movement of a mixed flow in which all participants are not obliged to move as a part of defined group. So who can move faster moves faster, and who is slow moves slower. Therefore, the proposed models do not work in the conditions of a school with inclusive education. The work presented by Lindiwe Rubadiri not only participants in wheelchairs takes into account, but also using crutches and other additional support. At the same time, the organized movement under the control of pedagogical worker was not taken into account. The reason is the same as the previous researchers. Naoi and Shimada regarded the movement of participants in wheelchairs, and they introduced new dynamic models for movement on turns and bottlenecks, narrow sections, and the influence of such bottlenecks and turns on the speed. At the same time, children were not considered as participants in the evacuations. Mahdi Hashemi, Kawai, Nurhayati, and other scientists performed works that were devoted to evacuation from educational institutions in case of fire, but they paid attention to organizational issues of evacuation from schools, in particular training drills and psychological preparation of pupils. Laurosdottir in Denmark and Nizhny Teslenko Tsimbolisty Kravchenko in Ukraine established the dependencies of speed on flow density during evacuation from preschool and school education institutions. However, in both works, homogeneous flows of children were considered. So, pupils with special educational needs were not considered in these works. So, as a conclusion of literature review, we can say that the most works of the movement speed of evacuation consider the speed as a function of one variable, which is the flow density, so the number of evacuation participants on 1 square meter. In secondary education institutions with inclusive classes, in addition to density, such indicators as a percentage of participants with reduced mobility, percentage of participants with special needs, yes, and the average age of the pupils will also affect the speed. Therefore, establishing a regression relationships between these indicators is an urgent task, and we devoted our work to solving these tasks. What materials and methods have we used? Due to method of dynamic video recording that we used, several evacuations, as we see on figure 1, several participants of evacuations have simultaneously used action cameras. These cameras were simultaneously recording the process of movement, and after the experiment was ended, we made measurements. The two recording of two different cameras we synchronized, and we could calculate what distance for the period of time was covered by the participants. Also, we could calculate by the equation number 2 the density, average density on that period of time. So we obtained data, and we made the data set of data in which such in which such in which we wrote such characteristics as speed, density, average age of evacuation participants, and the percent of participants using wheelchairs. We performed experiments on 3 different scenarios. The first scenario is the percent of participants using wheelchairs was 0, so the flow was homogeneous. Everybody have not used wheelchairs. On the second scenario, used we performed with 20 pupils, and one of them used the wheelchair. So the percentage was 5%. And in the third scenario, we used the flow in which 2 participants used wheelchairs, and the total number of agents was 20. So the percentage was 10. We haven't used the real children with disabilities. Our students from our university simulated their behavior. So we took our students, they took the wheelchairs, and they simulated the behavior of evacuation participants using wheelchairs. During the period of experiment, teachers and assistant of teachers helped the participants using wheelchairs to move. So we performed 449 measurements of different scenarios. We used also scenarios for different age of pupils. And so, as I said, the total number of um, measurements was 449. So this data set of our measurements we used to build the regression. We divided in 4 test and training data sets, and using Google Collaboratory, using Python language and the libraries of Python such as scikit-learn, matplotlib, numpy, pandas, seaborn, we perform the regression analysis. So at first we uh, you can show at the figure 2 speed and density scatter plot. Also, we explored the correlation between the predictors, such predictors as percentage of participants using wheelchairs, average age, and density. Yes, so we calculated the correlation between the predictors, and on the figure C you can see the correlation heat map. So it shows that the flow density has the greatest influence on the speed change. At the same time, an increase in density naturally leads to a decrease in speed. That is clear. Increasing the percentage of evacuees using wheelchairs also slows the traffic. An increase in the average age of evacuation participants leads to an increase in speed indicators. That is not the mystery for us. So the figure indicates low correlation of predictors among themselves, which indicates that the multicollinearity is absent. So we used linear regression model, and also we used a neural network for performing this task. Here you can see the regression coefficients established based on the results of model training, and we obtained such an equation which allowed to calculate our speed. The main results of linear regression are on the slide, and the mean absolute error was 4 and 4.12. Also, the coefficient of correlation was about 0.87. Also, we used the second method. We used a fully connected neural network. Initially, data normalization was performed using the mean and STD methods. The architecture of the neural network was represented by two layers of neurons. The first consisted of 128 neurons with the ReLU activation function. The output layer consisted of one neuron. The total number of trained parameters was 641. As in the previous case, the distribution of the dataset into the training and test samples was predicted in the ratio 80% the training dataset and 20% was the test dataset. Adam was chosen as the optimizer, and the mean squared error was chosen as the quality criterion. The mean absolute error accuracy metric was also chosen. After 100 training epochs, the mean squared error reached a value of 26. 95 on the training and 17.2 on the test samples. Mean absolute error reached a value of 4.04 on the training and 3.28 on the test samples. So the neural network show a bit better result. So the model of neural network also allowed us predicting the values of speed due to the predictors such as density, percent of people using wheelchair and average age. So that was very important result. Why? Because when we have a school, for example, and when we have the class where we have the amount of people, for example, 12 and one participant on a wheelchair, so we can take into account such parameters, so we can take the percentage, we can take the age, and we can build the dependency of velocity of speed and density. So this equation allows us to make more accurate calculation of speed of time evacuation duration from building in case of fire, and to improve the model, especially simplified analytical model that is used in Ukraine and in some countries for calculating, and this helps us to provide this model to be ready for such calculation, which was not done before. To approbate our model, we use the computer simulation. So we used the Pathfinder program complex, which is based on the individual model, and we performed the we simulated the experimental our investigations, and also we calculated by the Pathfinder the duration of evacuation. Also, we calculated the calculation using our equation which we had here. So, and also we used calculation due to the results obtained by neural networks. So the same scenarios were calculated, and here we have the results in seconds. for different scenarios. So we can see that when the flow is homogeneous, the Pathfinder provides the best results. We compare the results of calculations. This Pathfinder is a computer model, and here we obtained our models. So when there are no participants using wheelchairs in the flow, the Pathfinder shows the best result. But when the participants using wheelchairs are present in our evacuation flow, we can see that Pathfinder can't allow obtaining such result because the behavior of our flow is not good to be modeled to be simulated by individual model. So we have the results that prove that our models, the results of our work, can obtain better results in calculation, and they are convenient to use for calculation the duration of evacuation from educational institutions with inclusive classes. So, as conclusions, we can say that according to the results of on-site observation in secondary education institutions with inclusive classes, an empirical dataset has been created. The dataset consists of 449 measurements of the movement speed obtained in evacuation flow consisting of pupils with different ages and mobility groups on horizontal sections. What is mobility group? So people with using wheelchairs, it is one mobility group, and pupils using that do not use any support is another mobility group. So for the preparation of the obtained data, created prerequisites for using the linear regression algorithm and an artificial neural network to establish dependencies between evacuation parameters. The effectiveness of the proposed regression model has been verified by performing calculations using the result obtained in the work, as well as computer modeling of these scenarios, and comparing the determined values of the duration with experimental data. The best accuracy of the results, the deviation from the experimental values didn't exceed 15%, has been demonstrated by the model using a neural network. Dependency 3, which is here, Dependency 3 obtained using a linear regression algorithm and integrated into a simplified analytical motion model has demonstrated better accuracy of result compared to an individual motion model. The maximum deviation was 17 compared to 23. The results of the work can be used in calculations in the evacuation duration in school buildings with inclusive classes which include participants in